Hello friends, welcome to my channel on cryptography and digital security. So this is a three-part video wherein I intend to cover certain aspects of digital security. We'll first look at some basics. We'll look at what are keys, what are digital certificates, how do we create them, how do we create keys, and in my second part of the video I intend to cover usage of these keys. How do we use different types of keys to generate digital signatures? We'll do some practicals on that. And in my third part of the video, we'll see how the digital signatures are used for validating binaries. Basically, we'll look at secure boot, Linux secure boot. We'll see how various binaries at various stages of secure boot are digitally signed and verified to authenticate who's signing, and if it is a valid binary, should the binary be allowed to execute or not. So we'll look at various aspects of secure boot in my third video. So we'll start with some basics. We'll look at what digital keys are and what digital certificates are. So to start with, keys are nothing but random numbers. So every machine has a random number generator. There could be a hardware random number generator or a software random number generator. So there are mathematical formulas which utilize output of these random number generators to generate digital keys. So what are keys? You can take them as plain random numbers. Depending on the type of key, there could be some mathematical relationship between those numbers. So there are basically two types of keys. There are symmetric keys and asymmetric keys. So asymmetric keys, they're both random numbers again, but there is some peculiar characteristic of asymmetric keys. Now, asymmetric keys are or asymmetric cryptography is an encryption mechanism wherein two different keys are used. One key is used to encrypt data and another key is used to decrypt data. So these keys, the one which is used to encrypt and the one which is used to decrypt, they're different. So that's why it's called asymmetric cryptography. Now there's a mathematical relationship between these two keys. So the data which you encrypt using one key can decrypt it using another key only and nothing else. So the encryption and decryption keys are tied together by a mathematical relationship. Now, these keys are the typical size of these keys here is big. It's huge, say 1024 bits, 2048 or 4096 bits. So the key size is huge, and these keys are generated for a long-term functionality. So the minimum, say for example, in GPG, the minimum time for which you can generate a key is 1 day. So you can generate a key. Typically, companies generate RSA keys for say 20 years or 25 years. So the key lifetime is pretty huge. And these keys are generated per user or per entity. Say for example, I have a company, say Acme Corporation. So I create a digital key for my company. So this digital key identifies or this key packaged in a certificate identifies my company. So we'll look at certificates in detail later. So basically, asymmetric keys are a key pair. They come in a key pair. So when you create an asymmetric key pair, you create a private key and a public key. So they form a pair. Now, where are these used? For example, in digital certificates, when you want to do image signing or binary signing, you want to digitally sign something. So that's where you use your key pair to sign images. Another example is SSH authentication. Now you want to there could be nodes which want to authenticate. Say for example, my laptop, when I log into say a website, my laptop wants to authenticate the website to make sure that it's talking to a genuine website or not. So that's where digital signatures, say RSA keys or DSC keys, these are asymmetric keys which can be used for authentication. Just keep it at the back of your head. We'll look at details later, how they're used and so on. Now, asymmetric keys. say the simple thing is it's a key pair. You have a public and private key, all right, which is different from symmetric keys. Symmetric keys or symmetric encryption is an encryption mechanism where the same key is used for encryption as well as decryption. So whatever data you encrypt with a key, you have to use the same key for decrypting data. Now these keys are very small in size. There are like 128-bit or 256-bit, and the advantage with the symmetric keys is since the key size is small, the encryption is pretty fast. Now we saw asymmetric keys; they are of size 128 bits or so. 1024 or 20 sorry 1024 or 2048 bits, so they are pretty long, and encryption or decryption using these keys takes a lot of time compared to symmetric keys, which are short. Now symmetric keys have a very short lifetime. It's typically it could be for a few seconds to for a few minutes, or maybe a few days. So it's like, so these are transient keys which are typically created for a session. Say for example, when I log into a website through my laptop first uses asymmetric keys to authenticate the web server. So once authentication is done, they negotiate on a smaller symmetric key, which is then used to encrypt the actual data. Now these keys expire maybe in a few minutes, few seconds to a few days. Now, for example, SSH is another example where symmetric key is used. So in SSH, first you authenticate using maybe a username and password or digital certificates, and then once the other node is authenticated, both the nodes negotiate on a symmetric key. Now, this symmetric key will be used for the actual data encryption. IPsec is another example where once both the nodes authenticate to each other, they negotiate on a symmetric key which will be used for the ultimate data encryption. Now, public key cryptography. So, so typically, uh, asymmetric keys are used in public key cryptography. Now, these keys are used to validate the authenticity of a person or entity to whom the key belongs to. For example, typically a user will create a public-private key pair. We look at the commands to create how to create them. So once a user creates his key pair, that key pair becomes his identity. Not yet, until until he's attested by a certificate authority. So basically what happens is, if I for example, if I create a public private key pair, and it has all my details, my name, my company name, my country details, my location details, my website details, and so on. But how do people trust me? Now for people to trust me, somebody whom they trust has to validate that I'm a trustworthy person. Now that somebody becomes the certificate authority, or CA. So what CA does is, when I create my public private key pair, I give my public key to a certificate authority, say for example VeriSign or GoDaddy. Now the certificate authority looks at my name, my details, he validates everything, and once he's assured that I am the same person who I claim to be, once the certificate authority gets this assurance, the CA signs my public key. So once the CA signs my public key, which means once the CA starts trusting me, anybody in the world who trusts the CA starts trusting me. It seems quite complicated, but let's not get into the details in that. So my intent with this, the first part is just to give you a brief on what keys are. We look at these CA things later. All right. Now, what is a digital certificate? So a digital certificate, remember in my first two cases, we created a public private key pair. Now a digital certificate is a way of packaging keys along with the identity of the individual, along with details of the individual, plus the issuer details, whoever has signed that key, the details of the issuer, as well as the key itself, the public key itself, and a signature of the key. Signature of the key, signature this where it is signed by the CA. So basically, digital certificate contains an identity of the person who holds that certificate. It contains the name, the company name, the issue date, expiry date, issuer details, um, signature of the key itself, and a digital certificate can be of two types. So it's typically of two types. It's X.509 certificate, or it could be a GNU GPG, that is GNU Pretty Good Privacy. The X.509 is a certificate authority backed certificate, which means when I create a X.509 certificate, I need to go to a certificate authority and get my certificate or get my public keys blessed by him. Whereas in case of GPG, it is a web of trust based mechanism where when I go to a known person and I ask him to sign my keys, so he signs my keys, which means whoever is trusting him starts trusting me. So we build some a sort of a web of trust there. We look at some details of these. So first of all, we'll see how to create a key pair. We saw asymmetric keys. What are those? Now we are going to create asymmetric keys. So what are the commands to create asymmetric key? Openssl is a command where you request a new key embedded in a X.509 certificate with the key size 2048 bits, and my private key is stored in this file, and my public key is stored in public.crt, and I want my certificate or I want my keys to be valid for 1 year, 365 days, and the hashing algorithm used will be SHA-256. So we'll run this command and see what happens. So let me, I have this command here, key pair creation. All right. So let me run this, or let me delete the older files. Like, all right. See. Okay. So when I run this, it'll ask me some details. So when I'm creating a key pair, it's going to ask me some details. So which country does this key belong to? I'll say IN, state, some state, city, some city, some company, some or now all these fields are not mandatory. You can skip most of those. Email address abcd@def.com. You can use some address. So what we have here is a public private key pair created. Now we'll see what are the contents of this. You can look at the private key. So the private key basically contains modulus and exponent. Let us dump it. OpenSSL RSA minus in private minus. minus text. All right. So this is my private key content, which is nothing but a bunch of random numbers. So uh, which has a modulus and a exponent. All right. So that is my private key. Now the public key is embedded in a x.509 certificate. To dump this, openssl x509 minus n public cert minus noout minus text more. So this is my x.509 certificate which I created just now. So what it has is my issuer details, my subject name which I've gave now, country name, state name, city, company name, organization, email address, and it also has details of who has issued this key. Now in this case, I have issued this key. I have not got this signed by someone else. So the issuer details are all mine, same as what is subject details. So apart from this, encryption algorithm used, uh, RSA encryption algorithm. There should be yeah, and my public key, modulus, exponent, and what else? Signature algorithm. So this is a self-signed key. Now I have, so this signature is generated by this public key itself. So it's a self-signed key. All right. So we saw how to create a x.59 certificate, a key pair with and with a private key and a public key embedded in a x.59 certificate. So these commands are there in the description of the video. You can copy paste these commands from there. All right. So that's how you create a RSA key pair with the x.59 certificate based. Now, another way to create or package your public private key pair is GPG keys, or you can or GNU pretty good privacy. Now, the way to generate a GPG key pair is GPG minus minus gen keys. So let's see here, GPG minus minus home dir. Oh, this is not required. Let me just generate it. GPG hyphen hyphen gen hyphen key. Oh, sorry, key. Yeah. So this will ask you what type of key you want to generate, RSA and RSA. Let's select RSA. The key size, I'll select 1024. And when should it expire? I'll select two years. Yes. Real name, you can put whatever name. Say for example, I'll put my name abcd@def.com. My email address, test comment, everything okay. Yes. If you want to enter a password to protect your key, you can enter a password or else just keep entering. Now, this will go and read your random number generator and try to get enough random numbers so that it can generate a key. So depending on the machine, it might take a few seconds, a few minutes, or I don't know what. So I've seen it take a few minutes or beyond that. And to save some time, I have already generated a few GPG keys. Let me cancel this and let me show them to you. GPG minus minus list hyphen keys GPG. All right. So these are the keys which are generated previously. And to get more details on these keys, Run this command, list packages debug 0x02 GPG minus minus export minus A is for armored version. The key ID, you give the key ID by with GPG minus minus list packages minus minus debug 0x02. I think this is the one. List, I think it's packet, sorry. All right, so this is a dump of your GPG key. So it has again details. So these things here are not pretty straightforward. For example, if you see the created timestamp, it is in some format. You need to do some jugglery to convert this to the right to human readable format. All right, so I'm not going to go into details of what each of these fields are, because it's going to take another video session to do that. All right, so that is a brief. So what we've seen till now is digital keys are nothing but random numbers in a particular format, and there can be two types of keys: asymmetric keys and symmetric keys. Asymmetric keys are where different keys are used for encryption versus decryption. Symmetric keys is where the same key is used for encryption as well as decryption. Now the keys can be packaged into something called certificate. We've seen two types of certificates: X.509 and GPG. All right. So in my next presentation, hopefully we'll see how to use these keys to digitally sign binaries. We'll see some examples of how to use openssl to sign different kinds of files, different types of files. We'll see how to use say GPG keys to sign some RPMs. We'll see where those signs are, where those signatures are embedded or installed. Either they are appended or they are embedded inside the file, or in some cases the signatures are the data is enveloped in a signature. So we'll see some of those examples. All right, so thank you for your time. I'd love to hear your comments and suggestions. So the description has details on how to reach me. I'd be glad to hear your comments and suggestions. Thanks again.